video, I'd like to give you kind of an idea what goes into finding linear regression. You get all kinds of formulas and processes. And on this, I want to try and show you kind of what sits behind all of those formulas. And hopefully this will give you kind of a better conceptual understanding of what we mean when we say we do regression on something. So I've prepared a little desmos simulation, I guess, and it's here in your red folder called Linear Regression on Desmos. Now this is an optional exercise. If you want to pass on this, that is fine. But go ahead and click on there and we'll see if it comes up on the screen. Okay, so what we have here is we have 4 points, 2, 3, 2, 5, 12, 5, and 12, 7. And I've put those points on a little table right here. You could ignore the rest of this stuff for right now. I'll bring these up in a few minutes. So I've got these 4 points, and we want to find out where's the line of best fit for these 4 points. Now, just by looking at it, you could kind of see that the line of best fit is probably somewhere where the arrow's going back and forth. You could kind of almost envision a line of best fit. That would tend to follow the trend exhibited by these 4 points. And so, how do we find that? Well, really all a line of best fit is, it's kind of a middle. And so if you think about how you find middle of things, that's going to help you understand what regression really is. It's just about finding the middle. And so when you have a list of numbers and you want to find the middle, well, the way you do that is you average the numbers. And so we're going to use sort of the averaging concept as we go along here. So the way I'm going to start is I'm going to take these 4 points and I'm going to try to average them. So I have a little table over here of the x's and the y's, and the simplest way to do it is to start by saying, well, let's take the x's and let's find out what the average of the x's are. So if I take the 2, the 2, the 12, and the 12, and I've got a little calculator here, and so if I do, let's see, 12 plus 12 plus 2 plus 2, and then divide that by 4, because I've got 4 numbers here, you'll see that the answer is a 7. So the x's average out to a 7. And then if I take the y values and average out the y values, that would be 3 plus 5 plus another 5 plus 7. And so the average there is a 5. So the x's averaged out to a 7, and the y's averaged out to a 5. So let me kind of put that to the side and get back onto here. So I'm going to take what's called the point of averages, the x average of just 7 and the y average, which is 5, and I'm going to plot that point. And notice that point, that so-called point of averages, is kind of sitting right in the middle of the 4 dots that you have. And that ends up being an extremely important point when it comes to regression. That point is like the physical middle of those 4 dots. And the line of best fit always sits on the point of averages. So what I'm now going to do is I'm going to design a line that goes through this point of averages. And you might remember from previous classes something called point slope form. And so if I do y minus 5 and x minus 7, I do the y minus the 5 and the x minus the 7, and then put in a little slope value m. This is what's called the point slope form of a line. And so I'm going to go ahead and activate that. Okay, and so here I have a red line which goes through the point of averages. Now right now the slope is 0, and so this is a line whose slope is 0, but it goes through the point of averages. And I make this sort of variable so I can kind of change the slope, and as I change the slope of the line, I get various lines. So all these lines are lines that go through the point of averages, namely 7 and 5. Now it turns out one of these lines that I have in here is going to fit the 4 green dots the best. And so we want to talk about, well, how do we decide what's what's best. So I'm just going to go ahead and set this up right about here. Okay, and we're going to take a look at this line and see how well this line fits the 4 green dots. Now, what I've done here is I've created a little table that give you the residuals, the errors. In other words, if I go from 2, 3, which is right here, to the line, so from 2, 3 to that line, it looks like I'm a bit below, the point is a bit below what the line is predicting. It turns out right here, I'm below by negative 6.5. So this is negative 6.5 below. This point is sitting above the line, so it has positive residual. And the question is, well, how much residual is it? Well, according to the table here, it's about a 1.35, so about 1.35. So this is 1.35 above. This is about 0.65 below. And then if I go over here, this will be about 0.65 above, and you can kind of see that right here, 0.65 above. And this one is about 1.35 below. And so those are the 4 residuals. So here I have really just the four residual values. Now, you'll notice if you were to add all 4 of these residuals together, the positives and the negatives would cancel out. You'd get a total residual of 0. Okay? And so you go, well, that means I must have the line of best fit. Well, not necessarily. If I go ahead and try another line, maybe I'll move it over this way a little bit. Okay, and I look at the residuals, again I see the residuals are going to cancel out. The negative 1.4 and the positive 1.4, the 0.6 and the negative 0.6 are going to cancel each other out. So once again, the sum of the residuals is 0. In fact, anywhere I move along in here, anytime if I stop anywhere and I look at the 4 residuals, I'll see that I always end up with a set of opposites. So unfortunately, using the sum of residuals is not the way to find the line of best fit. The way we do that is, you may remember this from the other day, we have to look at all the squared residuals, and we ask ourselves, what's going to minimize or get us the lowest square sum of squared residuals, the thing we call SSE. So down here I've prepared a kind of a little formula. It's a little complicated, but what this is doing is it's taking all the residuals and squaring them and then adding them all up. And so right now, let's kind of go and set this up here. Right now I've got a sum of squared residuals 5.44. And the idea is, okay, keep playing with this slope until you get that sum of squared residuals as low as possible. So I'm going to go ahead and just start trying. If I move it this way, okay, whoop, my sum of squared residuals, I'm down to a 4.16. If I go this way, whoop, okay, so that I'm way off. So I know that I've got to move my slope this way. So I'm at 5.21. Now I'm at a 5 for the sum of squared residuals. I'm at a 4.81. I'm at a 4.49. So it seems as I increase this slope, I'm getting lower and lower squared residuals. So I'm now down to a 4.16. So keep going. Is 409, okay. 401, okay. 4, okay. So right now at this moment, I've got a sum of squared residuals of 4. Everything, this is a 1, this is a negative 1, that's a 1, that's a negative 1. So if you square them all, it's really just going to be 4 ones, and you add them up, you get a total squared residual of 4. Well, I'm going to go ahead and keep pushing and see if I can get under 4. Well, as I keep pushing, notice what happens. I start to balloon back up over 4. So it seems like right about, see if I can get there, right about there, there's the sweet spot right there. This is, whoops, see if I can bump that back a bit. Cursor's a little sensitive. There we go. So now I've got the line. This is the line of best fit. This is the one that has the lowest squared residual. So if I use a slope of 0.2, and then now I've got the equation for the line of best fit. So again, to recap, what you want to do is you want to find the point of averages, okay? And that's fairly easy. Just average the x's and average the y's. And then the second step is to come up with the right kind of slope that goes through those point of averages. And in so doing, you're doing what we call the regression process. And you keep playing with it, and eventually you'll find the one that's got the lowest squared residual total, sum of squared errors, and that's how you find the line of best fit. So feel free to take this desmos link that you have, and you can get in and modify it and play with it, and hopefully it'll help you get a little better understanding of what we mean by the residual process. Okay, thanks for watching.